Hey everyone, and welcome. Today, we're going to tackle something that drives pretty much every Java developer crazy at some point, getting error messages that are just vague and misleading. We're going to learn how to use multiple catch blocks to handle exceptions with surgical precision. The goal? Less time debugging, more time building. Let's dive right in.
You know the feeling, right? We've all been there. You run your code, it crashes, and the error message it spits out seems like it's from a totally different planet. It's confusing, super frustrating, and honestly, it's just a huge waste of time. But the good news is there's a really simple way to fix this, and that's exactly what we're going to walk through today.
So why does this even happen? Well, it usually comes down to a really common mistake, this one-size-fits-all approach to handling our errors. Let's take a look at what that actually means in code.
Okay, so take a look at this code. Inside our try block, we've basically set two potential landmines. First, a division that could end up being a divide by zero problem. And second, we're trying to access part of an array that might not even exist. But look at how we're handling it, with a single super generic catch block that just catches any old exception. Let's see what happens when things go wrong.
So, we run the code and we purposely trigger the array error. But what message do we get? Cannot divide by zero. I mean, seriously? That's completely wrong. And this perfectly shows the problem with that one generic catch block. It's just not specific enough to actually be helpful.
So how do we fix this mess? Well, the key is to think about it a little differently. I want you to imagine your try block is a hospital emergency room, and the exceptions? Those are the patients, and each one has a very different illness. Just shifting your thinking like this is going to make everything click.
This really lays it all out, doesn't it? Your code running in the try block? That's the patient walking into the ER. An error happens, that's the illness. Now, you wouldn't send a patient with a broken arm to a heart surgeon, would you? Of course not. You call in a specialist. And that is exactly what specific catch blocks are. There are specialists who give us the correct diagnosis, or in our case, the right error message.
And the great thing is, Java already has a whole team of these specialists ready to go. For any math-related problems, like division by zero, you've got ArithmeticException. For array index problems, you call in ArrayIndexOutOfBoundsException. And if you try to use something that's null pointer exception is on the case. Each one is an expert in its own little field.
Okay, enough with the theory. Let's get our hands dirty. We're going to go back to our original broken code and refactor it to put these specialists into action.
So, just a quick reminder, this is where we started. One try block, two potential ways for it to fail, and one generic, not-so-helpful catch block. We know this doesn't work.
And here's the fix. We've got the same try block, but now look what follows. Two separate specialized catch blocks. The first one is looking specifically for an arithmetic exception, and the second one is on the lookout for an ArrayIndexOutOfBoundsException. Let's see how this actually performs. First, we'll force the math error. We'll set the denominator to 0, and when we run it, bam! The code executes the first catch block because it's a perfect match and gives us the accurate message, cannot divide by 0. This is exactly what we wanted. Okay, now let's try the array error. This time, Java is smart. It looks at the first catch block, says, nope, this isn't a math problem, and skips it. Then it moves to the second one and finds a match. The output, stay in your limit. Now that is a precise, helpful error message. So now that we've seen how powerful this is, there is one golden rule. One thing you absolutely, positively must follow. This is a big one. I call it the Triage Protocol, and it's all about the order of your catch blocks.
Let's jump back to our ER analogy for a second. What do you think would happen if every single patient was first seen by a general doctor who just said, yep, you're sick, and then sent them home? The specialists, the heart surgeon, the bone doctor, they'd never even get a chance to help. And that's exactly what happens in Java if you get the order wrong.
Now, the technical reason for this is that Java's exceptions have a hierarchy, like a family tree. You have the main exception class. Think of it as the parent of all other exceptions. And then you have the specific ones, like ArithmeticException, which are its children. And here's the key. The parent class is so broad that it can handle any problem its children might have.
This means if you put that general parent catch exception E block first, it's going to grab everything. Your more specific child blocks will never ever be reached. Now, Java's smart enough to see this coming, so it won't even let you compile code like that. It'll just give you an unreachable code error. So remember the rule, always order your catch blocks from most specific to most general. All right, let's wrap all this up into a simple playbook. A few key takeaways that'll help you get your exception handling right every single time. Here are the 3 golden rules. First, use specific catch blocks. Your job is to provide accurate, helpful feedback, so don't be generic, be a specialist. Second, the order matters. Always put the child exceptions before their parent exceptions. Think specificity first, generality last. And finally, it's always a good idea to add a general exception catch block at the very end. Think of it as a safety net for any weird, unexpected errors you didn't plan for. Always have a fallback plan.
See, when you follow this playbook, you're not just fixing bugs. You're actually designing better, more robust, and way more user-friendly applications. You now have the tools to turn those confusing, frustrating error messages into clear, actionable information. Now go put them to use.